Hey guys, I might jump back over to Desmos again. That's why it's looking so big, a little blurry here. So if you want to look at those graphs again, just email me and I'll let you play with the stuff that I have, or I'll share the stuff I have on Desmos with you. So transformations of rational functions. So let's say I have 1 over x minus a, or sometimes h. Okay, this is our horizontal shift here. And then I have x minus b over x minus a. Let's look at that real quick. Oop, not that one. That's just your guys' videos. There's Desmos. Okay. So there you've got your horizontal shift. Doing the opposite thing, right? If I have minus, negative, it becomes plus. Now, look at what happens if the x's match and the b's match. So they're getting closer and closer together until, look, they are together. Now, you might think that that's just because a is 0 and b is 0, but if this were x over x, what would you get? Well, x divided by x is just 1, so you're getting an output of 1 here. There, they're growing left and right, depending on which way you pull that back and forth. I think this is supposed to be. Okay, let's look back at our notes real quick. Okay, so we've got transformations on rational functions. I'm going to see if I can get this to focus again. Sorry guys, the lag is really bad. Let's see if this fixes it. There we go. Okay. So there we have our horizontal shift transformations. So let's just quickly run through these notes on the video. So horizontal asymptotes, that's what we were just exploring on Desmos. So as x approaches infinity, what happens to our function? As x approaches negative infinity, what happens to our function? Now, if you are struggling with this, the best way to really understand what's going on with horizontal asymptotes is to get on Desmos and try playing with it a little bit so you have a better idea of why this works so you can visualize it. So if I take a really big number like 1,000,000 and I square it, I get 1,000,000 squared over 1,000,000 squared. Well, if I add 1 to 1,000,000 squared and I add 3 to 1,000,000 squared, it doesn't really matter. I'm almost looking at 1,000,000 squared over 1,000,000 squared. So when I go to simplify this, these right here don't even really count anymore, okay? So the largest power equals the denominator of the largest power. So if the two powers are the same, you're going to get A over B. Okay. A over B. Here's matching one. Got these irrelevant value and irrelevant value. Again, if you want to plug this into Desmos and then grab the mouse and go as far that way as you possibly can. So maybe zoom way out and then shift it or change the window to be something that you're interested in, like 10,000 or 20,000. You don't even really need to go that far. 100 or 200 is far enough that you can really see that when you plug in 1,000 and you multiply it 1,000 squared by 3 and you add 1,000 and you add 2 and then you take 5 times 1,000 squared plus 2,000 plus 1, you're still basically getting 3/5. So you're not actually going to get there because you do have these other values that are going to pull you slightly above or slightly below that 3/5. So you're never quite going to get there, but you're going to try really, really hard. That's what a horizontal asymptote is. So other method or ways of thinking about this is if you divide out the largest variables. So let's say I take everything and I divide all of the terms in the numerator by x squared. Well, this is going to become 3. This is going to become, well, if I take x and divide it by x squared, where I have 1,000,000 divided by 1,000,000 squared, that's basically 0. Or I take 2 and I divide it by 1,000,000 squared, that's basically 0. Okay, same thing across the bottom. These are going to become basically 0 when I divide out that x squared. So I'm pretty much left with just this 3 over just this 5. Or they're the only values that really have any weight because these ones are going to become so small and insignificant they're not really weighing into the total output. Okay, so that's type 1 where the powers match on the largest one. Okay, here's type 2 where the largest is in the denominator. Okay, so the denominator power is larger than the numerator power. Again, we get something irrelevant, and we're just left looking at these. So you can do the same thing where you divide out the x cubed being our largest one. We are going to get x squared over x cubed plus x over x cubed plus 2 over x cubed. And then this all becomes x cubed over x cubed. And let's say there's like some number there, a. Plus 5x over x cubed plus 1 over x cubed. So this guy is going to approach 0. This guy is going to approach 0, and this guy is going to approach 0. If you don't believe it, try it with a number. Try it with something like 10,000. This is going to become 1 over 10,000, right? So 10,000 squared over 10,000 cubed becomes 1 over 10,000. Well, 1 over 10,000 is pretty insignificant. So 0 and then 0. Here we're having lots of weight in the denominator, lots of weight in the denominator, lots of weight in the denominator. The only thing I'm really left with here is some really small number in the numerator divided by a bigger number here. Okay. Now if you take something small and you try to split it among a whole bunch of things, I'm going to be getting closer and closer and closer to 0. So you can check that one on Desmos 2 if you want to try and play around with those a little. Maybe give yourself a slider here, see if it makes a difference. You can make this x to the 5th and this x to the 4th. It doesn't really matter. If this guy's bigger, you're going to be approaching that 0. Okay. Then we're going to go through 1, 2, 3, 4 quick strategies that we need to do every time we graph a rational function. So we'll come back and we'll do that in just a minute.